Hello again. This is Math 2232 coming to you from the College Edu page. The title of this video is Midterm Exam Key for Spring of 2024. And as always, please be attentive while watching this video. Problem number one asks you to evaluate this series, or at least decide whether it converges or diverges. And so the approach to this is to identify f of n is equal to 1 over n times the natural log of n whole squared. And you should note that this f of x is greater than or equal to 0, and that it's decreasing for x bigger than or equal to 2. That means you can use the integral test, and so we can compute the definite integral from 2 to infinity of 1 over x ln of x whole squared dx. Using this substitution, we get that this integral does converge. It is 1 over ln 2, and so by the integral test, the original series converges. Number two, a similar problem. You were to determine whether this converges or diverges, but also I asked that you sum the series if it is possible to do so. And in this case, it is possible to do so, because you can use partial fractions on the sum end, and you will get 1 over 6 n minus 1 over 6 times n plus 6. And so if you write that out, you will see that from 1 over 7 on, it cancels out. So what is left is a telescoping series. This is 1 over 6 plus all of these numbers. You add them together, you get 147 over 360, or dividing both top and bottom by 3 in lowest terms, you get the sum is 49 over 120. And so that's what you should have done to earn full credit. Similarly, you were to study this series, the summation from n equal 1 to infinity of n plus 1 over n. Well, you can note here that the nth term, a sub n equal n plus 1 over n, converges to 1 as n goes to infinity. So by the nth term divergence test, this series diverges. Number four, you were to determine whether this series converges or diverges, but you also were to sum the series if possible to do so. And it is, because 5 is 5 and 23 can be factored out of this. But then what remains is a geometric series starting at 1 over 10 squared. And the ratio that you get is 1 over 10 squared, or 1 over 100. So you get 5 plus 23. The sum of this geometric series is the first term, 1 over 100 divided by 1 minus r, which is 99 over 100. So this is 5 plus 23 times 1 over 99. That's 5 and 23 over 99, or if you change that into an improper fraction, that is 518 over 99. And so you should have summed this for full credit, and that's problem 4. Here's problem 5. You were to evaluate this integral. It is important that you note this is an improper integral, and the place where the denominator goes to 0 is at x equal 1, which is in the range of integration. So you have to evaluate this as an improper integral, taking the limit as t tends to 1 from the left for this one, and the limit as t tends to the right for this one. And so you evaluate those here and here, and you take the limits, and you get 3 plus 3 times 2 to the 1/3 power. So that is the answer you needed to get to earn full credit. Here's another improper integral to evaluate. You go from minus infinity to infinity of dx over 1 plus x squared. Since the integrand is even, you know that this integral from minus infinity to infinity is twice the integral from 0 to infinity. And you can evaluate this using a substitution. X is tan theta. Dx then is secant squared theta d theta. As x goes from 0 to infinity, theta will go from 0 to pi over 2. And so this then, when I make this substitution, I will get 2 times the integral from 0 to pi over 2. The secant squareds will cancel out. That's just theta. So it's 2 times pi over 2 is equal to pi. And so that is what you should get to get full credit for this problem. Here is number 7. You have to do polynomial long division. And when you do that, you get that this integrand becomes 2x plus 5x minus 3 over, and factoring the denominator, I get x minus 3 times x plus 1. I can do partial fractions on the second one, so I get 2x plus, this is 3 over x minus 3 plus 2 over x plus 1 dx. Then you integrate it, you will get x squared. Here you will get 3 ln absolute value of x minus 3 plus 2 times ln absolute value of x plus 1 plus the constant of integration. And that could have been written this way. I would count either one of those correct. And so that's how you get full credit on problem 7. Problem 8, you were to evaluate this integral. This is going to be a trig substitution. And so this is the triangle that you get, and so we're letting x be 3 sine theta, dx is 3 cosine theta d theta. So we substitute all that in. The 3 cosine theta will cancel, and I can pull out the 9. So this is the integral of 9, and that is sine squared theta d theta. Now this is going to be 9 times, I have to use the trig identity for this, 1 minus cosine 2 theta over 2 d theta. And so when I integrate that, I will get 9 times theta over 2 minus sine 2 theta over 4, then plus c. But then you have to use, in order to reverse your substitution, you have to use the trig identity that the sine of 2 theta is 2 sine theta cosine theta. So if you do that, we get it as our final answer that this is 9 over 2 arc sine of x over 3 minus, this is 1/2 of x, 1/2 x times the square root of 9 minus x squared, because that's sine theta and cosine theta. And then I'm going to say plus c. So that is what we get for that answer. Number 9, you were to evaluate this definite integral from 0 to pi over 4, the square root of 1 plus cosine of 4x. And so you use the trig identity here, that the thing that's under the square root is 2 cosine squared of 2x. You take the square root, you get square root of 2, which you can pull out of the integral, and then you're integrating from 0 to pi over 2 cosine 2x dx. You get sine of 2x, and you do have to change variables, and so you get this 1/2. On the outside, again, you plug in the numbers. Sine of 0 is 0, sine of pi over 2 is 1, and so the answer to this problem is 1 over the square root of 2. That's what you needed to do to get full credit on this problem. Here, this is going to be integration by parts. You let u equal arc sine of x squared, so du is 1 over square root of 1 minus x to the 4th times 2x dx, and dv is going to be x dx. That means that v is going to be 1/2 x squared. So you do integration by parts. The 2 is on the outside of the integral, so you evaluate, this is uv minus the integral of v du. And you calculate the integral. You have to do another substitution here of u, and you calculate the integral. And at the end of the problem, you will get pi over 12 plus square root of 3 over 2 minus 1. So that's what will give you full credit for this problem. Here is number 11. We want to find the length of the graph of f of x equal x cubed over 12 plus 1 over x as x goes from 1 to 4. Well, here is y. So if you take the derivative with respect to y, the derivative of y with respect to x, you get x squared over 4 minus 1 over x squared. And then you square that. Now when you square that, for the middle term, you get minus 1/2 because the x squareds are going to cancel out. And so you get x to the 4th over 16 minus 1/2 plus 1 over x to the 4th. But then when you add 1 to dy dx whole squared, that minus 1/2 changes to a plus 1/2, and that really is x squared over 4 plus 1 over x squared, and that's whole squared. So when you take the square root of that, as you do with the formula, you just get x squared over 4 plus 1 over x squared. So the arc length then is the integral from 1 to 4 of this one. That should be dx. You substitute the value in, you perform the integral, and you get an answer of 6. So that's what you should have done to get full credit on this problem. Here you're supposed to find the, let's see, the problem says the region enclosed by the x-axis in this parabola is being revolved around the vertical axis x equal minus 1, which is over here. To generate a solid, you want to find the volume of the solid. The easiest way to do this is to use the shell method. So this is 2 pi. R is going to be x plus 1, and h is going to be 3x minus x squared. And so we integrate that from 0 to 3. You multiply all this stuff out and make a substitution here. So you have a minus x squared, so you get 2x squared plus 3x. That's minus x cubed dx. You do the integral and multiply by 2 pi, substitute the numbers in, and you get 45 pi over 2 as your final answer. That's what you needed to do to earn full credit on this problem. Number 13, we were looking at the region bounded by the parabola y equals x squared and the line y equal 2x in the first quadrant is revolved around the y-axis. To create a solid, you want to find the volume of the solid. This is going to be the washer method, and so this is going to be pi big R squared minus pi little r squared, and you have to be drawing your slice this way, or at least I think this is the easiest way to do it, to do the washer method. And so you're integrating dy, and so you see the function that's furthest away from the y-axis is x equal y squared, and when you square that, you'll get y, and so when you integrate y, you get y squared over 2, evaluated at 0 and 4, and the inner one is going to be x is equal to 1/2 y, so when you square that, you get 1/4 y squared. You integrate that, and you'll have 1/4, that's going to be y cubed over 3, and you plug in those values again and do the arithmetic, and you get 8 pi over 3 as your solution to earn full credit on this problem. Finally, number 14, you were to find the area of the region in the first quadrant bounded by y equal the square root of x. Looks like this. The x-axis, which is there, and the line y equal x minus 2, which is here. But we're in the first quadrant. So you see you're going to integrate from 0 to 2 of the function on top is the square root of x. The function on bottom is y equals 0. So 0 to 2, you do that one. Plus from 2 to 4, the function that is on top is the square root of x. But the function that is on bottom is minus the whole of x minus 2. And so you do some algebra and perform the integration, do the arithmetic, and you get as an answer 10 over 3. And so that is the answer that will give you full credit for this problem. In closing, God bless you all. Look forward to seeing you in class, and we'll look ahead rather than back as we finish the course. Take care. Bye.